So welcome to baby class. We're going to look at descriptive statistics to discuss how to summarize the tables, the charts, the graphs, to look at what an OGIV is, a stem and leaf diagram. So I'll start with what you know to what you do not know. So the main focus of descriptive statistics for many of you is simply to know how to summarize data and interpret it. This is in fact one topic that you end with at school in research, where you need to do your research for data analysis and presentation. So I'm going to ask you to understand descriptive statistics and how you can present data to a layman. So we have a number of tools that we're going to use in displaying statistics. They are what we call frequency distribution tables. They are what we call histograms. They are what we call bar charts. They are what we call scatter diagrams. So all these are important for you. Now, these pictograms, you may have seen them from somewhere, but I need you to identify them for me and tell me what they are. So I'm going to draw a column of 6 things. I'll number them 1, 2, up to 6. 1, 2, 3, 4, 5, and 6. And you help me identify what each one of these are. So we have something like this. 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 And we have something like this. So help me identify polygon 1, 2, 3, 4, 5, 6 quickly. What is polygon 1?
Box whisker. Box whisker.
Box whisker plot, correct? Yeah. Box whisker plot. Do you agree with her?
Box whisker plot.
Yes.
Yes.
Number 2.
Pie chart.
Pie chart.
Pie chart, correct. Number 3.
Bar chart. Bar chart.
Bar chart, correct. Number 4.
Graph.
Number 4 is what?
It's a graph.
The scatter plot. Number 5.
Histogram.
Histogram. And number 6. And create a frequency graph or cumulative frequency depending on how projection is. All right, so at least I'm happy you're able to identify these pictograms. Now, I need us to understand that these pictograms are able to distinguish 2 types of data. There's what we call quantitative data, and there's what we call qualitative data. quantitative data and qualitative data. What is the difference? What is quantitative data and what is qualitative data? Anyone?
So quantitative quantitative data, it's basically numbers, the data that is in numeric form, and qualitative is the theoretical part of the data, like, yeah, the theory parts, like the information itself written. That's what I understand.
Okay, great. Anyone else? That's good. Yeah. So she's saying qualitative data is simply quality information. Quantitative data, she's saying, is quantity information. Information that you can measure, you can weigh. All right. That is quantitative. Can you give me examples of quantitative and qualitative data? So quantitative data, like she said, is subdivided into two. There's what we call continuous and discrete. Discrete is simply the whole numbers, like 1, 2, 3, the number of times you come into class, the number of children you have. They're countable, they're distinctive, they're discrete. But continuous, these are fractions or integers. They are found in between. Like your age, your weight could be 1.3, your height could be 1.73. It has decimal points, so that is quantitative continuous. We have qualitative, can be ordinal or nominal. Can be ordinal or nominal. If it's nominal, it is discrete. For instance, you are either born in Zambia or Zimbabwe, can't be born in two. But if it's ordinal, you can be a mixed race colored, which is white and black, or Tonga Lozi, that is what? Ordinal data. You are a mixed. So quick, can you remember? Data is classified into quantitative and qualitative. Mention any two types of quantitative data. Two types of quantitative data. Number one. Pardon?
Are those quantitative data as well?
What?
BP readings. BP.
BP readings, yes.
Look at BP readings. Can this, yeah.
Yes, what type of quantitative is that? What type of quantitative is that? Is quantitative discrete or quantitative continuous?
Continuous.
Yes, it's continuous. All right. So it has a range, it's continuous, it is interval. Between an interval, it's continuous, under interval. You can be hypotensive or hypertensive. Yeah. So, yeah. How about the weight of your baby? What type of data is that?
Continuous.
Yes.
Has got also intervals because it changes over time.
Yes, it's a quantitative continuous here. It can be an obese and underweight. Yeah. All right. Okay, so now at least you know what types of data we have. We can quickly rush into what we call frequency distribution tables. So this data we have here refers to the demand of hammers for 20 days. So we're being asked to present this data in a frequency distribution table. So we can show the relative frequency and cumulative frequency. So to start with, the integers or the figures here we have are hovering between 0, 1, 2, and 4. How many zeros do we have in here? We can literally count them. We have 1, 2, 3, 4. So frequency of the zeros is 4. The ones there we have 1, 2. So the twos there are what? The ones are 2. The twos we count 1, 2, 3, 4, 5, 6, 7. Twos are 7. The threes there we have 1, 2, 3, 4. There are 4. The fours there we have 1, 2, 3. So when you total up, we're getting a 20. This is called our frequency distribution. If you want, you can use a tally as well. You tally. Remember the italic. The zeros are 4, 1, 2, 3. Tally. Let me put the Y in here. So 1, 2, 3, 4. The two ones are 2, 1, 2. The twos are 7, 1, 2, 3, 4, 5. This is how we write 5, 6, 7. So the twos are 7. The threes are 4, 1, 2, 3, 4. The fours are 3, 1, 2, 3. Are we following? Are we together?
Yes, we are.
Then if they ask you to find the relative frequency, RF, relative means out of the total, out of the 20. So this is 4 out of what? 20. Can leave it in decimal, which is 0.2. The 2 simply 2 out of 20, which is 0.1. The 7 is 7 out of 20, which is 0.35. The 4 is 4 out of 20, 0.2. And the 3 out of 20, which is 0.15. Maggie, are we together on how to come up with the relative frequency?
Yes, we are.
Yes, we are following.
All right. So if you ask to find the relative cumulative frequency, we now start adding. Okay, this is how we find the relative frequency. Now let me take you to the cumulative frequency. Cumulative means add on. So if I'm going to start the cumulative frequency, which is CF, I'll just start. We add a 4. 4, you add it to the 2, you get a what? A 6. 6, you add it to the 7, we get what? 13. 13, you add 4, we get what? 17. 17, you add 3, we get what? 20. This is how we come up with the cumulative frequency. In the relative cumulative frequency, you start the way we're doing. This is 4 out of 20. Don't add this column, man. Just consider this column, the last number you have here. If you want, you can start from below here. This is 20 out of 20, which is 1. The last number is always 1. And this is 17 out of 20, which is 2. This is 13 out of 20, which is and 6 out of 20, then 4 out of 20. That is how we found the relative cumulative frequency. Are we together before I move?
Yes, we are.
All right, so I explained to you how to find the frequency. We divide it over to 20, we get these ones here. The other way for finding relative cumulative frequency, having found the relative frequency. To find the relative cumulative, you can also do the add-on the way I told you. You start with 0.2, then you add to this answer you got there, you get 0.3. Then you add to this answer here, the 0.35, you get 0.65. And you add to 0.20, we get 0.85. Then you add to 0.15, we get a 1. It's also the same, it's also allowed. So this is how we find the relative cumulative frequency. I'll take my time. This is a BID class, so should anyone be behind, just raise your hand. I'll repeat everything. Are we together at this point?
Yes, we're following.
All right, so this is what we're just doing, we're adding up. So the relative frequency, we just add up. Now, there are times when the problems are sporadic. They are spread irregularly. In this case here, it was easy to get 1 up to 4, but here the dispersion is kind of high. We have 1, but the highest number there is 14. Do I need to do 1 up to 14? No, it's not relevant. You can classify them. Now, this classification, you need to find an appropriate class size. There's a formula we use. All right, so 2 to the power k should be greater or equal to n. So you need to, so the sample size here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So the sample size n here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6 times 5 is 30. So you need to now find a number that you're going to power the 2 to exceed this 30. So I was telling you to come up with a mini table for yourself, which looks like this. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, up to 7 somewhere there, if you like. So this 2 to the power 1 is 1, 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, 2 to the power 5 is 32, 2 to the power 6 is 64. So we're interested in these powers. So which number first exceeds? Remember, our sample size was 30. Which power first gives us a number that first exceeds 30? So 5 first gives us a number that exceeds, because 30 somewhere there. So meaning our k is equal to 30. So now what is this? Our k is equal to 5, sorry. Because 2 to the power 5 is 32. So this helps us now identify the appropriate number of classes. So firstly, you find the range. The highest number here is 14. The lowest number is 0. So 14 minus 0, you divide it by the 5. The 5 is coming from what I'm just explaining. So 14 minus 0 divided by 5. All right, 5 is the number of classes which are suitable. So 14 minus 0 divided by 5, we get 2.8. To the nearest, it is 3. Did you get me right on that one?
Yes, we did.
All right.
Though I've got one question.
Yes, please.
I understand the working out on the 2 to the power, but I wanted to ask if possible. I know maybe sometimes in exam you have got limited time to be multiplying by 2. Is it possible? I don't know how to find it on a calculator, like, because I understand some they just put the number and then to the power. Don't know how you can help me on that.
What calculator are you using?
I'm using a GS350 MS. Is it? I think. I don't know how I can share it. Can I take a picture? I don't know how I can do it. Or maybe you can just show me any calculator that maybe, because some I think they have similar of where you can find to the, I think, other similarities. Like there's NPR, some they're using NCR. I think.
Okay, so the most common two calculators we have is the Casio, and we also have the Sharp. So I'll explain for both of you, please. It's very important. Your calculator is a computer that most of you do not know. So there's still much that you do not know that you need to learn about your calculator. So I will take her through firstly both calculators, the Sharp and the Casio. Even if you're using Kenko and other ones, they all fall under Casio. So I'll explain these two. So if you have a Casio calculator, it looks something like this. So this calculator to the power has a symbol that looks like this. So 2 to the power 3 equals. For the Sharp, you're going to find something that looks like y to the power x, something like that. So press 2 to the power 3 is equal to 8. Kindly confirm, all of you, that's what you're getting. So you're to the power is somewhere here. Of course, I think my picture is a little bit blurry, so I don't know. Can you try to find 2 to the power 3 and 2 to the power 5 on your calculators if you have them there? I confirm with the.
I have found it.
Okay, now find 2 to the power 5 equals, don't forget equals
32.
32.
32.
So that's how we find.
Thank you so much. I've been wanting to look for it for a long time. Thank you.
All right. I'm glad you have arrived. Those ones that also use a calculator like this. This is a Sharp calculator. Go to the power is here. It comes as y power x. So you can put any power, maybe 10 to the power 3 and equal sign. Are we together?
Yes,
All right, so this is how this 5 was identified. Then you can now start your numbering. So when you're doing the numbering of non-inclusiveness or inclusiveness, how many numbers are between 0 and 2? And how many numbers are between 3 and 5? How many numbers are there? Please check.
I'm saying 4. I don't know if I'm right.
How many numbers are between 0 and 2? And how many numbers are between 3 and 4? No, not in the here, just the class width. So here, the way we class width The numbers that we're looking at, the width here is what? Is 3. We're looking at the numbers 3 itself, 4, and 5.
Mhm.
The class width between these numbers is 3 because there are 3 numbers here, 3, 4, and 5 itself. All right. Even here, 0, 1, and 2. So how do we treat these 3? We're going to start with the class width, the smallest number. So
I have a question.
yes, please.
So when you're saying the numbers between 3 and 5, you said there's 3, 4, and 5 itself. You don't have to consider the 3.1, 3.2.
Yes, we are looking at discrete numbers, yes. Based on this data set. So we want to come up with a class width. So I'm trying to see how we're going to use these 3. Because a mistake somebody will make will do 0 to 3. Then they'll start 4 to 7. Meaning you've gotten your class width wrong. This class width is wrong. Because these numbers 0, 1, 2, 3, there are 4 numbers in this width. So you need to start 0 to 2. How many are they? Yeah, 6 numbers. 3 to 5. Yeah, 11 numbers. 6 to 8. So here what I'm interested in is the class width here. You can identify the class width also by looking at this height here from here to here. What number do we have? We have a 3. From here to here, what number do we have? We have a 3. Anywhere from here to here, what number do we have? We have a 3. So this is your class width. Don't look at it from here to here because when you subtract 2 minus 0, you get a 2. 3 minus 2 minus 3, we get a 2. That is not how we get the class width. So this 2.8, we round it up to 3 approximately. So we are calculating the class width 0 to 2, 3 to 5. Others would want to just put it like this. If you put it to say 0 to 3, then 3 to 5, then 5 to 8. It's also correct, but don't include the 3 in there. In your mind, the 3 must be included in here. That is what should be in your mind. So I'm trying to also be very careful to explain that.
I think the way you are putting it is the right one because the second one confuses also when you're counting the numbers. You end up making a mistake on the frequency. I think I've made that mistake before.
So what are you saying? Which one are you comfortable with?
I was saying that, yeah, I'm saying the first one, the 0 to 2 one, you are correct. It's good at when you're identifying the numbers in the frequency table. But the second one, as you were saying, the 0 to 3, it's more confusing when you
Yes, this one is more confusing.
I'm saying I'm preferring the first
Yeah,
option.
because if you have a 3, your question is where do you put it? You put it here or you put it here? So rather you move with this one here because you may end up duplicating figures. So just say 0, 1, 2, the class width is there. 3, 4, 5, 5. So that's that. So the selecting of these ones, I don't want to explain so much because this is obvious to take the whole day for me to start checking on them. But I want you to get the concept here. Like, what are we learning? How to calculate the what? How to calculate our class width using our knowledge of the suitable number of classes. All right, using the suitable number of classes. So this is where the assignment also was coming from. You were being asked here deliberately, calculate the number using a suitable number of classes. Calculate this into frequency using the suitable number of classes. So here we have 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6, 7. So 6 times 7, what do we get? Is 56. I count again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So we multiply this, we get what? 56. Now, what is the number of classes that we're going to use? Remember, 2 to the power 5.
Collins, we get 42, not 56.
Oh, we get 42. Okay, thank you so much. 42, yeah. So 2 to the power 5 is 32. And 2 to the power 6 is 64. So we don't pick this 5 because this answer doesn't exceed this. The next number is 6. We will pick a 6 because 2 to the power 6 is 64. So what we do the class we did now. The highest number minus the smallest number. Find the range divided by what? By the 6. So that is the reason why we did what we did in the assignment. Okay, so this rule must be used in coming up, and whenever we're not given the number of classes to come up with. So it is very important that you understand what I've just explained. Any questions?
It's clear. Thank
All right. So the relative frequency, like I explained, after finding the frequency over 30, you divide each of these ones into by 30 to get the decimals. After getting the decimals, you add them to get the cumulative frequency. So 0.2 plus that, you get that. This by that, you get that. This plus that, you get that. So this is how we get this. Then we go to the histograms. Now remember, the type of data will also help you identify what type it is. So we're looking at the grades for statistics class. There's grade A, grade B, grade 3, but you are being asked to draw a histogram. Now, grade A and grade B, they don't meet. Okay, if you get 60, maybe to 70, 60 to 64, that is a B. Then 65 to 75, that is maybe an A. So these ones are discrete, they're not continuous, they don't intersect. So this is a histogram. Ideally, it's supposed to be attached like this. But instead of us attaching it, we're going to put what are called tags. So A, B, C, and D are already explained by these ones. But inside here, we're going to put a table for maybe how many got an A, how many got a B, we put them there. How many got a C, we put them there. So this is also a histogram. It qualifies because of these tags there. But we can't mix these ones because if you get 74, you may end up being an A or a B. So this is a histogram, but there are gaps that exist between the data here because these are countable possible letters A, B, and B, C, and D. These ones are discrete. So this is not a bar chart, okay, but it's a histogram, but it has tags here. These ones are intersecting, but inside here we put how many got an A, they are 9. How many got a B, they are 12. I need you to understand that very clearly. It doesn't obliterate the initial lesson I talked about. Is that clear?
Yes.
Yes.
All right, then also,
And I've got a question.
yes, please.
Hi, Collins.
Yes, please.
I was saying, I wanted to ask, what determines that this should be on the y-axis and this should be on the x-axis on the graph?
The frequency is always on the y-axis, then the classifications are always here on the y. Quite all right, depending on how your key is. It is not a problem if you're going to draw your graph like this, because if you go to Excel, some of them look like that. as long as you understand them. But for your exam purposes, the frequencies, usually put them there, and the class category usually is on the horizontal axis. All right, so we go to a different type of data. On the histogram we know. So we are given information regarding what? The commuting distance for 50 employees of a particular what? Company. So those that commute 0 to 4, they are 3. 4 and under 8, they are 10. 8 and under 12, they are 6. So here we have no gap between, because this data is continuous. The distance that we have, 1.9, 1.9, this is continuous data. That's why it was important for you to understand the type of data we have, whether it's discrete, whether it's continuous. So for all continuous data, it looks like that in a histogram. For all discrete data, we need to put tags. So I need not to explain any further. Remember, every bit of what I explained is key and vital. Any questions? We proceed. Information here showing the mileage of a car. Is mileage of a car? Expect this question in a test or an exam. So we're given the information showing the mileage of a car. So in this case, we have been asked to come up with the class using that rule. So we have information here. Remember, to find the width, the largest number minus the smallest value over the number of classes. So when you multiply this 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 40, our n is 40. So to find the number of classes, it's supposed to be 2 to the power what? To exceed 40. 2 to the power 3 is 32. 2 to the power 6 is what? 64. So we're going to get 6, not 5. 5 gives us 32. So 6 here. So our largest number was 318, the smallest 365 over 6. We get 8.89. So here we can round up depending on the data that we have. So a class of rounded up to 10. Why not 9? Why not 8? 10. So it's admissible data. This just gives you a range within which you will have your classes. Okay, sometimes the examiner would actually limit the class width yourself, class width that you use. So here we've rounded up to 10. And also observe the smallest number is what? 318. But we're not going to pick 318. We're going to pick smallest number is 265. We're not going to pick 265. We want to work with numbers in tens. So I can start with 265 to 270, 270 to 280, 280 to 290, until 310 to 320. So it engulfs all these numbers there intelligently. Right? You may not need to specifically start at 265. You keep adding 10. You can intelligently have your class width to capture the whole data. So between 260 to 270, how many are 2? 270 and under 280, how many are 2? Until you go to 310 to 320, how many are they? 390. Now, mileage, what type of data is it? Is it continuous or just discrete? Mileage.
Continuous.
Continuous, good. So meaning these will be in a continuum. All right, so data will look like that. So this is how the histogram will look like. All right, so
This question.
yes, please.
Why did we round up to 10 when it's 8 point? Why didn't we round up to 9?
I think I explained that even if you round it up to 9, it's still okay. All right. There are two things that were done here. We rounded up to 10 because we want to work with a class width of 10. You can use tens. For numbers that are big, sometimes you can use a class width that will 5s or 10s. These are easy numbers to work with. And also we adjusted, instead of starting at 265, we adjusted to 260 to capture this range. So you are at liberty, it's still okay.
All right, okay, thank you.
Then we have such data here. Again, the 6, because this is 40. Then the range, so this we have 3.667, so rounded up to 4 ideally. Then the smallest number is what? 26. So we can start with 25 to 28, 29, 32, 33. So this information here that we're looking at regards what? The number of home runs. Okay, the number of home runs hit by baseball players. What type of information is that? Can you run 3 times? Yes. 4 times? Yes. 4.5? No. So the number of runs is a discrete information. So this one is discrete data. So we're going to use what? Tags for the histogram. So when we go here, we have the tags, these tags here, tags there to show that it's a histogram, but the information will be having gaps because you can't hit 38.25 for instance. So that information cannot be in a continuum. Bar charts, on the other hand, you will not have gaps. All right. So I will end here for now. Unless there are any questions, and I'll send follow-up questions to help you, guide you. Remember, those of you who are not in the paid up group, just ensure you're in paid up to access the videos. These videos are only sent to paid up members. So I will end here for now. Have a great day.